Добрый день, уважаемые слушатели. На прошлом занятии мы с вами посмотрели видео, в котором описывается основной принцип работы термокалк, на чем он основан, да? Основные термодинамические базы данных, которые там используются. И сегодня первое видео по построению разрезов. Давайте мы его с вами посмотрим. Сейчас я все настрою. Приступим.
Is an easy way to learn how to use ThermoCalc in the graphical mode before you know how to work with ThermoCalc projects. It walks you step by step through setting up a basic calculation using a simplified workflow so that you learn what information is needed to set up calculations in the program. To begin, open ThermoCalc in the graphical mode. Click on the Quick Start button from the home screen of ThermoCalc. A window appears where you can select from among the 4 most common types of calculations. In this example, we will calculate the phase fractions as a function of temperature for the stainless steel SAE 304, so we will use the one-axis equilibrium calculation. This used to be called property diagram, so if you have an older version of the software, select that. Now click Next. Here you select the thermodynamic database and elements you will use for your calculation. I will select the database TCFE10 and the elements iron, chromium, nickel, molybdenum, manganese, silicon, and carbon. The first element you select will be dependent, but that can be changed later. In a regular setup, this information is selected in the System Definer, so a System Definer node appeared when we came to this window. Now click Next. Notice that an Equilibrium Calculator node has also appeared. Here we set the composition of our system and define the variable that we want to vary. You also set the composition unit here. Leave the composition unit as mass percent and the temperature as 1000 Kelvin. Notice that iron is grayed out. That's because it's dependent and cannot be changed. But if you delete the value of chromium, for example, iron is no longer dependent and can be given a value. Chromium becomes dependent. In this example, we will set chromium to 18%, nickel to 8, molybdenum to 0.6, manganese to 2, silicon to 1, and carbon to 0.15. This automatically sets iron to 70.25%. Let's set the temperature definitions from 500 to 1750 degrees. Make sure all your values match mine, then click Finish. A number of activities are automatically created and configured according to the settings in the wizard, then the simulation will take a few moments to run. You can check the event log to make sure the calculation is running. Once the calculation is done, the results will appear in the results pane to the right. The results of this calculation are shown as both a table and a plot. If you click on the nodes in the project pane, you will see the settings we set. For instance, if you click on the System Definer, you will see the elements we selected. And if you click on the Equilibrium Calculator, you will see the composition we set. You can make changes in the configuration window and run the calculation again. For instance, let's select the Plot Renderer node and uncheck the boxes next to Automatic Scaling so that we get a better view of the plot. Change the upper limit of the y-axis to 1.1, then select Perform at the bottom center of the program. This plot shows the mole fraction of the phases formed under equilibrium conditions at the defined temperatures. Each colored line represents one phase. If you hover your mouse over a line, you will see the phase name, followed by the temperature and the mole fraction of the phase. The plot also gives phase transformation temperatures, so you can see the stability windows of different phases. For instance, you can see the ferrite stability window from about 1520 degrees to about 1730 degrees. ThermoCalc also allows you to configure the plot by right-clicking on it and selecting Properties. You can change the font size and color, change axis labels, change the image quality for saving the plots, and much more. You can also add labels to your plot by right-clicking and selecting Add Label. You can zoom into the plot by dragging your mouse down and to the right over the plot, and zoom out by dragging your mouse up and to the left. Notice you also have a table that shows the same results as the plot. Both the table and the plot can be exported in various formats. Simply right-click over either, select Save As, and choose the format you prefer. You can also change the resolution of images here. Any labels you added to the plot will be saved in the images you save. You can also save the entire project, which allows you to return to it later and share it with others. To continue learning about ThermoCalc and the add-on modules, we recommend that you watch the Getting Started video or any of the examples videos available on our website at www.thermocalc.com. The quick
На этом это видео заканчивается. Потом мы приступим к следующему нашему видеоуроку.